Hey guys, this is Dr. Callahan for Algebra 2 Semester 2 for week 15 Thursday. How are you guys doing? Go ahead and pause the video and answer the following 3 questions for your warm-up. Okay, that's enough time. All right, we're gonna move on. So first thing, remember this is the breakdown of your grades. Every week you guys have 3 grades going to the grade book. The first grade is your Math Excel for the practice questions. Second grade is your Math Excel for the assessment on Wednesdays. Third grade is the stuff that you turn in class with the check marks. And so each of the 10 means this. If you're never here, you're physically not here, you get a 5, and that is your curve. It's a 50%. If you're here and you have no check marks and I don't have anything from you, you get a 55%, because I think there should be a difference between people who show up versus people who don't show up. If you do turn it in, but you get like a check minus because it's not completed, you'll get like a 60-70%. And then a B is an 8 out of 10. And then if you complete everything, you get your check pluses, you get a 9 or a 10. So those are kind of like the grade breakdowns, okay? All right, so you guys know the safety grade, there is no curve. We are almost done with week 15, you guys. So once that's done, the only one that's left is 4 more weeks until finals. Your safety grade is a 75%. After the final, there is no curve. There is no other opportunities to do or, turn in assignments. The last day for you guys to turn your assignment is the day of your final. So while you guys are taking the final, I will be updating your grade. So anything that you need to turn in, you give it to me the morning of when you take the final, not after the final, because after the final, I want to grade the final, get the grades done. And then after that, I'm going to start packing because they're going to demolish this building. And so I really don't have any time to give you more assignments, have you turn it in. So don't even ask, because my answer is no. Okay. So I've been pretty understanding of late work up to this point. You can turn in anything that you've done since week 1 Monday for this class. That's totally fine. Remember, there is a 10 to 40% deduction, but even with a 40% deduction, you'll still get like a 60%, which is better than a 0. You know what I mean? And so just keep that in mind. But the last day to turn anything in is a day of the final. So what did we do last class? If you were not here last class, and if you're like, where do I get this? It's actually right there. It's the third one, because you guys are third period. I have all the assignments that you guys missed up there on that red bookcase. You guys are welcome to take whatever you want. And generally, if you look at the very bottom of those worksheets, I have like the days right here and the weeks. Do you guys see that right there? So like this one says week 15 Wednesday. So when you go to the YouTube channel, you just watch the video for week 15 Wednesday, and I'll give you everything that we did in that class. So you don't have to be good at math to pass this class. You just have to go ahead and do the work. So we went over graphing and modeling exponential functions yesterday. A lot of it was on the calculator as well, because it's really difficult to find these numbers if you're to do it by hand, especially when the numbers are so darn small like this, for example. So that's why I said in this class, you can use a calculator on your final, but what good is it to do it on the final with a calculator if you don't know where the buttons are? You know what I mean? So you have to learn to use your resources, be tech savvy, and learn where the buttons are so you can use it on the final. So that's what we did yesterday. In addition to that, remember this week, you guys have your 10 questions practice problems, and then 5 questions for your assessment. So that's due on Sunday, so don't forget about that. And then if you take a look at the YouTube channel, I already added the one from yesterday, and I do this every day, and I know it seems a little bit mundane after a while, but I do it so that way I can also check where I am to make sure that I didn't forget to upload anything. And I think maybe I did. There's 67 videos. And I did. I don't see 15 Wednesday here. So that tells me that I forgot to upload it, but that's okay because I'm going to do it right now. So I'm going to go to Zoom. And there's your video from yesterday. And I want to make sure I go ahead and label it so that way when you guys see it on the YouTube channel, that you know what skills we're going over. So let me just go ahead and label that. Okay, I'm going to take that video. I'm going to post it over here on my folder for Dropbox. And then I'm going to go to YouTube and then upload it. And I'm going to wait for that thing to pop up. And then I'm gonna drag this over here. So if you're ever curious about how you can make a YouTube video, I'm showing it how you can do that. All right, and then public, publish, close, and then I'm gonna put this one into the folder for Algebra 2, semester 2. Save. Okay, so you should have this there soon. So there should be 68 videos then. All right. So today we should be on logs, but we're not because we're just like a few days behind, but that's okay because I'm going to shift all of this for next week. So we'll talk about logs, then we'll talk about properties of log on the following week, and then we will end probably right here. You don't have a test, so we'll end right there. And then from there, then we'll have literally a whole week to review, which I'm going to go over the study guide with you guys. And on the study guide, the questions are the same, similar questions that'll be on your test. And it's from the same people who made your test for your finals from the state. And then we'll go over that. And then we take the final, and then that's it. All right, so today is Thursday. We're going to talk about modeling exponential functions for day 4. I'm going to go over my notes on solving modeling exponential functions. You do need to have a TI-84, and then you're going to have to do a poster project today with a rubric, which I'm going to give you the material. So you need the handout, TI-84, poster, Sharpie, and then iPad. So there's like 5 things that you need to come up and grab. So grab a handout, which is right here. Your Sharpies are going to be right over here. The TI-84s, you already know where it is. And let me give you the poster. And here's the poster. Let's do, oh, I have several different colors. You can just pick one up. Okay. So I have yellow and green and pink and purple and blue. So come on up and pick a color of your choice for your posters. Here we go. Sharpie, poster board, and then you will be turning in the poster in today, so make sure you guys complete that, and then I will give you guys your check marks. All right, so let's go ahead and proceed forward with what you're doing. So first thing to have you guys do is take a look at your handout on the right side. We're still modeling with growth and decay, but growth and decay, now we're going to kind of move it towards like either population growth or in terms of money and investment to see whether you lose a lot of money or you gain a lot of money. So I'm going to start off on the right side, right over there. Okay, so in today's lesson, you're going to learn how to write exponential functions to solve problems in which a quantity increases or decreases at a constant rate. We're going to do one of 2 things. You're going to go ahead and write using exponential functions given the initial quantity, that's the keyword, and the percentage growth or decay rate. So that's the first objective. And the second one is you're going to determine the initial quantity and the percent growth rate by solving and using your brain for critical thinking. Okay, so let's start off with the first one. So read the rabbit problem first. And then read A and B. And make sure you have a TI-84 calculator because you're going to need it today. Okay, so you have a rabbit, and the population of rabbits has R of X equal, or R of T, not X, T is for time, is equal to 5, parenthesis 2 to the T. So the first thing that you need to know is that, remember, the 5 is your initial value. The 2 is going to be your multiplier. So that 2 right here is your multiplier. And then also remember your 2 is going to be B, and your initial value is A, right? And then it's always to the X. So keep in mind, if B is greater than 1, remember it will be a growth. If B is smaller than 1, it is a decay. So you want to copy that part down first, just so you know what they represent. Okay, so then A says how many rabbits were in the population when it was discovered. What would this represent on the graph of R? So when it was discovered, that means the initial value is, well, when it was discovered, the initial value is 5, right? So you will just say initially 5 rabbits. Okay, that's how you started off with. And where would this be on the graph? 5 equals Y on the Y axis. And that's it. So if this is your graph, you will start your graph at 1, 2, 3, 4, 5. Boom. That's where you will start your graph. Because you start out with 5 rabbits, and the way I see it is like they're probably gonna be mating, so your rabbit's gonna go up in an exponential growth. So now let's take a look for B. So it says determine the number of rabbits in the population after 4 years. So in that case, T equals 4. So I'm going to rewrite my equation. R of 4 equals 5, parenthesis 2 to the 4th power. So grab your calculator and then insert that into your calculator. How many rabbits are you going to have in 4 years? So you start off with 5 rabbits. And this is where your calculator comes in. And again, you want to make sure you practice using your calculator so you know where the buttons are. And especially if you're planning on going into like pre-calculus and trigonometry next year, or if you're planning on going into like something that might be math related later on in life, let me just tell you, you're going to be using your calculator for a very long time. So you might as well learn now where all the buttons are. So if you don't know where it is, that's okay. We're just going to go right here. We're going to hit 5, parenthesis 2, use that little triangle for the exponent, put 4, and then you just hit enter. So how many rabbits do you have after 4 years? 80 rabbits after 4 years. And that is your answer. But you started off with 5 rabbits. Okay, let's move on over. So this is the model of exponential growth and decay. You can go ahead and read that. First thing I want you guys to notice is a difference in the equations for exponential growth and decay. The big difference is, do you see how inside the parenthesis, it's 1 plus the rate, and the rate is a percentage of growth. And if it's 1 plus R, it will be bigger than 1. Right? And that's why we affiliate with a number bigger than 1 as growth. On the other hand, if you do 1 minus R, you know your B is smaller than 1. right? And so therefore it should be a decay. So that's kind of where it comes from. All right, so with that said, let's go ahead and take a look at example 1. Before example 1, if you were to convert percentage into a decimal, it's always the number divided by 100, or in this case is 0.13. Or if you guys remember this back in like 2nd grade, do you remember your teacher taught you like the decimal is always at the end, and then you move 2 spaces over to the left, and boom, that's your new decimal. So 13% is like 0.13, okay? So looking at example 1 right here, it says the value of a pack of baseball cards was sold for $12, increases by 7% every single year. And they want you to write a function for V of t to show the value after so many years. So looking at the square, where you guys have all the square formulas, are you going to use the left equation or the right equation? That's probably the first thing you want to think about. And once you determine that, I mean, I would think that because it's increasing, that would indicate growth, right? And so if it means growth, I will be using the square on the left. And so in that case, you'll do a equation like V of t, because that's your equation, which is the value of the baseball cards after t years, equals how many baseball cards did you guys have initially? Let's see. Oh, the initial cost was $12. Okay, so that's your initial cost. So you put 12 right there. That's your initial cost. It's going to increase by 7% each year. So that's 1 plus 7% is 0.07. So 0.07 to the t. And then if you simplify this, it's just 12 times 1.07 to the t. And that is your answer. For B, they actually want you to figure out how much your card's going to cost, your 12 different, or how much your card's going to cost, although it costs initially $12, okay? After 2 years, how much is your pack of baseball card going to be worth? So in that case, this is where you grab your calculator. You do V of 2 is 12 times 1.07 to the 2nd power. So grab your calculator, type that in. Yep. Oh yeah, go for it. Do you want to choose right here first? Cool. So grabbing your calculator, and let me go ahead and do that with mine as well. Let me grab my calculator. Here we go. Okay, so with your calculator, you're going to put 12 parenthesis inside 1.07, close your parenthesis, and then use your little caret and make sure you put a 2 right there and then hit enter. Okay, so in 2 years, your baseball card really is not growing that much. You get $13.74. So what does that tell you? That tells you the investment of baseball cards is probably not a great investment. You probably should get an education, I don't know, get a better job. Okay, so let's go on to the next part. So I'm gonna have you guys flip your paper over to the back. So baseball cards and bunnies are one example of exponential growth and decay. Here are some other examples that you use in real life of exponential growth and decay. If you take a look at example 2, one of them is on chemicals and especially with radioactive substances. Okay, so go ahead and read example 2. So there's a radioactive substance with a mass of 140 grams. Okay, so this is how much you're starting off with. 140 milligrams, I should say. It's decaying at a rate of 15% per day. So automatically, I know 15% is the same thing as 0.15. So I'm just going to convert it right now. For A, they want you to write a function m of d on the mass of the substance after d days. So you start off with m of d is equal to your initial value that you're starting off with is 40 milligrams. So that's 40. Inside your parenthesis is going to be your growth or decay. Well, given the fact that it's saying it's decay, it's going to be 1 minus the percent it's decaying. So 1 minus 0.15 or 15%. Okay. And then D is going to be your days. So then after that, you just need to simplify it. So M of D is equal to 40. 1 minus 0.15 is 0.85 to the D power. And that is your equation. So A is done, so you could check that off. For B, they want you to round to the nearest tenth of a number in milligrams of the substance after a week. So how many days are there in a week? There should be 7, right? So then you're going to do M of 7 is equal to 40 times 0.85 to the 7th power. Grab your calculator and you want to insert that in. Oh, you might want to grab the paper right here, my dear, so that way you have it. And also on the poster and then a Sharpie and an iPad. So 1, 2, 3, 4. Yeah. All right, so let's go ahead and grab my calculator. You guys should have your calculator as well. You should really try to do this on your own. Don't just wait for me to give you the answer, because I'm going to tell you right now that it doesn't really work that well for me to just give you the answer. I promise you. All right, so let's just do 40 parenthesis 0.85, close your parenthesis, use your little exponent marker, type in 7, hit insert, and then initially you had 40 milligrams. After 7 days, you now have 12.82 milligrams of this material. So your answer is 12.82 mg, and that's your answer. All right, so now that we've done this fancy work, I'm going to have you guys do something a little bit more complicated because you're a smart group of kids. And I really believe that teachers need to raise the bar, because if you teach the kids more difficult stuff, they will come to that challenge. I really do. I'm really sick and tired of some of the teachers like watering their curriculum going, well, my kids can't do this. This is too hard. And I'm like, no, if you never teach them the hard stuff, they're never going to get better at it, you know? So I think you guys are a smart group of kids, so I'm just going to teach you guys some more harder stuff. So this is now kind of going into a little bit more of like pre-calculus. So determine the initial quantity and the percent growth decay rate. So example 3, the number of beetles in a population after W weeks is given by this function. So that's what they're giving you, okay? What is the y-intercept? And what does it represent in this problem? Well, so far, that's not so difficult. The y-intercept is, as you guys know, going to be the initial value. So the y-intercept equals initial value. Well, what's the initial value of this equation? It's always on the outside of the parenthesis. So in that case, it is 47. And what does that represent? That represents the number of beetles in the population, because you're starting out with 47 beetles. Go on to B. B says, what is the percent rate at which the beetles population is increasing per week? Well, then the increasing part is you're looking at the inside of the parenthesis. So what that means is that your multiplier for growth is equal to 1.015. And because B is bigger than 1, you know the population is growing. It's not decreasing, it's growing. And how much is it growing per week? It's the growth by, if you look at this, remember 0.015. You got to convert that into a percent. So 1, 2 spaces to the right, which is 1.5%, right? So it is growing by 1.5% each week. So now you're just kind of like working backwards. You know what I mean? Okay, still doing good, still with me so far? Okay, so far we talked about radioactive substances, we talked about bunnies, we talked about beetles, we talked about, I forgot, what else did we talk about? Hold on. Oh, baseball cards, that's right, cost of baseball cards. Now another one that you can talk about, think about what can grow, what can decay. Another one is the value of your car. Okay, so we're gonna go on to example 4. And this might be our last example for sake of time. So let's go on to example 4, example 2. Oh, I already have it here, duh, all right. Okay, so example 4, it says the value of the car in dollars is represented by this function right here. So they're giving you guys the equation and they want you to interpret what it means, okay? T is the number of years it's purchased. When you guys buy a brand new car, the minute you drive your car off the car lot, your car is no longer worth that amount anymore. So yeah, so a lot of people buy used cars because it's a little bit cheaper that way, but I don't know, sometimes people like a new car because there's just something special about having a brand new car. Nobody has ever driven it, but if you drive it off the car dealer's lot, you lost like a few $100s there. So what was the value of the car when it was purchased? So what they're asking you is the initial value. And remember, your initial value is always going to be on the outside of the parenthesis. So that's $34,000. So as I'm thinking about this, like, what kind of a car is this? It's definitely not a Maserati, or it's not, you know, like a BMW. It's probably like a Honda or a Toyota. I'm thinking maybe a Subaru, yeah, for $34,000. If it's brand new. And you definitely don't have leather seating. It's probably just regular cloth seating. All right, so then what is a percent rate at which the value of the car is decreasing each year? Well, for that, you want to look for the multiplier, which is going to be inside the parenthesis right there. Well, if your multiplier is 0.74, and remember, it's always 1 minus the percent, or decimal, I should say. So 1 minus 0.74. So in this case, it's going to be 0.26, right? And then if you move that into a percent, because that's a decimal, go 2 spaces over to the right, which is a 26%. So your car is depreciating in its price by 26% each year. That's horrible. That's not good. That means your car is going to lose a quarter of its value every single year that you have it. Okay. So you might as well just buy a used car, right? Because if you buy a used car, then you're already getting a discount from that. Okay, so I'm going to be done with this. We're done with it. So if you're done with it, awesome. Go ahead and stop that for now. We're going to move on to your poster. So now that you guys have gone over several different examples about exponential growth and decay, take a look over here on the left side. So where it is highlighted right now, this is going to be your 5 different things you have to do. Okay, you're going to create a title. I don't care what title it's going to be. It's yours. Include an exponent rule. include the equation with the values, like the common factor and the multiplier initial value, draw a diagram of the decay, create a word problem, and then give me a table value. Okay, so it's kind of like when we did the matching. When we did the matching, remember, there's always like an equation followed by a table, followed by a graph, right? And there's always like a scenario, like if it's bacteria growing or, you know, car depreciating. So if you take a look at the left side right here, this is my example of what I did, but yours could be a little bit different than mine. That's totally fine. And then you guys have your rubric on the very bottom, which is right here. Your total is going to be out of 100. You're not presenting. Your presentation is essentially just, you know, you turning it in and me looking at it. Okay. All right. So with that said, you guys have about 16 minutes for the rest of the class, about 20 minutes, I should say, to go ahead and complete this. So grab your Sharpie, grab your poster, and go ahead and get started. You guys also have example of this on your white paper that I passed out to you guys. So you will be turning this in today. If you're like, I don't know what examples I should use, look at the yellow paper. There's so many different type of examples, and you just need to use your creativity to create one. Okay. If you guys want to write it in a different language, that's totally okay by me as well. Yeah. All right. Happy working, you guys.